Welcome everyone. We complete our lectures, pressure inside the body. Now we study the pressure inside the skull. As we see, this is the skull, and this is the ventricles that contains the cerebrospinal fluid. The brain contains approximately 150 ml of cerebrospinal fluid in a series of interconnected ventricles, as we see here. This is the lateral ventricles, and this is ventricular foramen, and this is the aqueduct, which is a narrow opening channel. The cerebrospinal fluid is generated inside the brain and flows through the ventricles into the spinal column and eventually in the circulatory system. This is the spinal column, in which the cerebrospinal fluid is flowed and eventually to the circulation of the body. One of the ventricles, the aqueduct, this is the aqueduct, as we see here. This channel at birth is closed for any reason, and increase and closed the cerebral aqueduct. It trapped the cerebrospinal fluid inside the skull and increase the volume of the skull, and this is what is called hydrocephalus. Simple method of detecting hydrocephalus is the measuring of the circumference of the skull above the ear. Here we can determine if the person or if the newborn infants have hydrocephalus by measuring the circumference of the skull above the ear. Here we measure the circumference just above the ear. Normal values for new infants range from 32 to 37. More than this value, the infants indicates hydrocephalus. The second pressure we study here is the pressure in the eye. As we see from here, the eye contains of clear fluid, which transmit the light to the sensitive parts of the eye, which is the retina. Light sensitive part, which is the retina. This is the retina. Sorry for this is the clear fluid. In the front parts of the eye, it's the aqueous humors, and this is the lens, and the fluid behind the lens is the vitreous humors. This fluid inside the eye control the eye at constant or fixed shape and size, and any change in this diameter affect the clarity of vision and change in the dimension of the eye. If 0.1 millimeter change of this dimension or dimension of the eye causes a significant effects on the clarity of vision. The pressure inside the eye range from 12 to 23 millimeter mercury. The eye continuously produce aqueous humor, and there is a drain system allows the cereblus to escape out of the eye. This control a special control the pressure inside the area. If the drain system of the eye is closed for any reason, the aqueous humor which is produced in front parts of the eye will increase the pressure inside the eye, and this increase in pressure restrict blood flow to the retina, which is the sensitive parts of the eye, and this increase in pressure cause the restricted blood flow to the retina, and this retina, and this is acts to the damage of the retina and causes what's called glaucoma. The eye pressure is measured in an instrument called tonometer. The measure of the which is the measure of the amount of indentation produced by known forces. The third pressure we study here, the third pressure we study here is the pressure in the skeleton. Pressure in the skeleton, as we know, the pressure equal force per unit area. As for a given force, the pressure is reduced as the area is increased. Bone has adapted in another way, reduce pressure. To reduce pressure, the finger bones are flat rather than cylindrical to reduce pressure in the tissue over the bones. We can explain this adaptation, or we can see this adaptation in the bone at the bone joint. If we have this bone, we see the adaptation in the bones, that the area at the joint, if there is a joint, area at the joint, area at the bone joint is large. So for a given force, as we know, pressure force over area, when increased area, as we see here, the pressure is reduced in the bone joints. The last pressure we study here is the pressure in the urinary bladder. As we see from the figure, this is the pressure volume curve for the bladder. As we see, the pressure in the bladder due to accumulation of urine in the bladder. As we see, this is the pressure in centimeter H2. This is the axis, y-axis, and the x-axis, the volume in ml, which is the volume of urine accumulated in the bladder. As we see, as the volume of the urine accumulated increases, the pressure also increases, and at some pressure about 30 centimeter H2O, the voiding will occurs, or person goes to voiding urination or urination at this pressure. The typical volume before voiding, the typical volume of urine inside the bladder before urine, about 500 ml of urine. An increase in the accumulation of urine inside the bladder causes a high muscular contraction inside the wall of the bladder and reach up to about 150 centimeter H2O. Therefore, it must be urinate. We can measure the pressure inside the bladder by inserting a catheter in a urinary passage, and this catheter have a sensory pressure to measure the pressure inside the bladder, during pregnancy, the weight of the fetus over the bladder increased, the bladder pressure, and cause frequent urination. This is the end of this chapter, divided into 3 parts, and you can see the 3 parts. That's one I explained. The 3 parts is the important parts of the lecture. You can depend on what I explain in the video, 3 parts of the video, to insist in this parts of the lecture. It's important. One that I neglect, it is not so important, but you must read. Thank you.